In this video, we will look at the iterative function to perform search operation in binary search trees. We will have the function as search, which will take key as the parameter. The very first statement is to create a variable, that is a temporary root, to hold the initial value of the reference of the root of the binary tree. In the next statement, we will use a while loop, while troot then. This while loop is used to move the reference of the troot variable from the root of the binary search tree till the leaf node. Within the while loop, we will check if the key we are searching is equal to the element present in the node. If it is present, then we found the element, so we return true. But if the element we are trying to search, that is the key, is less than the element in the node, then we will move the reference, that is troot, to the root of the left subtree using the statement troot equal to troot.left. But if the element we are trying to search, that is the key, is greater than the element in the node, then we will move the troot variable, that is the reference troot, to the root of the right subtree. This process continues until we find the element, or else we have reached the leaf node and there is no left or right subtree. Then the while loop will terminate without finding the element. In this case, we will return false, that is, we have not found the element. So this is how search function works. We will take an example and I will trace this function to have a clear understanding of its working. Let us consider that we are trying to search element 6. So search function is called passing element 6 as the key. In the first statement, we have troot is assigned the root of the binary tree. So troot will be having the reference of the root of the binary tree. Then we have the while loop, while troot. Troot is not empty or it is not false. Since troot is pointing to a reference of the node, troot is true. And within the while loop, the first statement is to check whether the search element or key is equal to the element within the node. So the condition 6 equal to 5 is false. The statement within the if statement will not execute. Then we check if the key is less than the element in the node. That is 6 is less than 5. This statement is also false. So the statement within the if-else will not execute. Then we have the else-if statement, which checks the condition that the key is greater than the element within the node. That is 6 is greater than 5. This condition is true. So the statement troot equal to troot.right will be executed. This statement will move the troot reference to the root of the right subtree. So troot is pointing to node 5. Now troot will be pointing to node 8. That is the root of the right subtree. Now since we are in a while loop, the condition for the while statement is checked again. Troot is pointing to a node and it is not null. So the statement within the while loop will be executed. That is, if key is equal to the element within the node. So key, that is 6, equal to element within the node is 8, which is false. So the statement within the if statement will not execute, and the next statement, that is else if key less than troot dot element will be executed. The condition, that is key 6 less than the element in the node, that is 8, is true. So the statement, that is troot equal to troot dot left will be executed. This statement will move the reference of the t root to the root of the left subtree of node 8. 6 is the left subtree of node 8. So t root will now point to node 6. Since we are in a while loop, the condition of the while loop is checked. That is, t root is still referencing a node. So t root is not null. So the if statement is executed. In the if statement, we have key equal to t root dot element. That is, the key is 6 equal to 6. That is the element within the node. Now this condition is true, so the statement within the if statement will be executed. That is, return true. That is, the element 6 is found in the binary search tree. Let us take another example of searching element 7. The search operation is called passing the element 7 as the key. The first statement, that is t root equal to root, so the variable t root will be referencing the root of the binary search tree, that is node 5. Next we have as a while loop, while t root then. Since t root is referencing a node and it is not null, the statements within the while loop will be executed. The first statement is to check if key is equal to the element in the node. That is, key is 7 is equal to element is 5 within the node. This statement is false. So we check if key is less than the t root dot element. That is, if 7 is less than 5. This statement is also false. So the function checks if key is greater than the t root dot element. That is, if 7 is greater than 5, which is true. So the statement t root equal to t root dot right will be executed, which will now point the t root reference to node 8, which is the root of the right subtree of node 5. Since we are in a while loop and t root is pointing to a node, the statements within the while loop will be executed. The first statement is key is equal to the element in the node. That is, 7 is equal to the element in the node, which is false. So this statement will not get executed. Then we have a statement if key less than t root dot element. That is, key is 7 is less than the element in the node is 8, which is true. So the statement t root equal to t root dot left will be executed. This statement will move the reference, that is t root, to the root of the left subtree of node 8, that is node 6. So t root will now be pointing to node 6. We are still in a while loop. The condition of the while statement is checked, that is t root is still pointing to a node. So the first statement, that is key equal to t root dot element, is checked. That is, 7 is equal to the element within the node is element 6, which is false. So we move to the next condition, that is key less than t root dot element. Key is 7, which is less than t root dot element. Element is 6. This statement is also false. So within the while loop, we need to check if key is greater than t root dot element. That is, 7 is greater than 6, which is true. So the statement t root equal to t root dot right will be executed. Now since there is no right child for node 6, t root will now point to null. The condition in the while loop is checked again, that is t root. Now t root is null, so the condition of the while loop becomes false and the statements within the while loop will not execute. Following the while loop, we have a statement return false. This statement will be executed and the value returned is false. That is, the element 7 is not found in the binary search tree. So this is how the iterative function to perform search operations in binary search trees work. Finally, let us compute the time complexity of the iterative search function. To search an element, we have to perform comparisons at every level of the binary search tree. In worst case scenario, we need to perform the comparisons at each level of the binary search tree. So the number of comparisons made depends upon the height of the binary search tree. The statements within the while loop will execute till the element is found, or in worst case, till the last level of the binary search tree. So therefore, in worst case, the number of comparisons made are h plus 1, where h is the height of the binary search tree. So we can say that the iterative search function of the binary search tree takes O of h plus 1 as the time complexity, which is equivalent to the time complexity as O of h. So this is how iterative search function of the binary search trees work.